we've seen how you can differentiate inverse function of sine, right? Now, we are having cos inverse of x and tan inverse of x. How do you go about it? For the first one, same idea, right? For the first one, y is equals to cos inverse of x. Solution. The first thing first, when it comes to y equals to cos inverse of x, we want to find the derivative. By derivative, we mean dy dx, right? Recall, when you have y is equals to 2x, you are asked to find the derivative, meaning you have to differentiate. You are differentiating y with respect to x. That is dy over ds. Of course, by the time we differentiate, you have 2, right? That is, dy dx is equals to 2. Similarly, given this function, y equals to cos inverse of x, I'm asked to differentiate y with respect to x, dy over dx. Alright, here's how it works. Recall from indices, 1 over a is still the same thing as a raised to the power of minus 1. Similarly, a raised to the power of minus 1 is still the same thing as writing 1 over a. Likewise, 2 raised to the power of minus 3 is still the same thing as writing 1 divided by 2 raised to the power of 3. Alright, applying this law to the given question, initially we are given y equals to cos inverse of x. We can as well as write this as y equals to cos inverse multiplied by x, right? Implementing this idea to cos inverse, then this becomes y equals to 1 over cos times x, right? Multiply, then you have y equals to, of course, 1 times x. You simply have x divided by cos. Alright, call this equation 1. From equation 1, cross multiply. By the time you cross multiply, you have that x is equals to cos y. Call this equation 2. Alright, from equation 2, by the time you differentiate, you have the x over dy, meaning that y is a function of x. Then the x over dy is equals to minus sine y. Call this equation 3. From equation 3, we solve for the x over dy. But the question says that find the derivative of this function, that is dy over dx. Then how do you get dy over dx? Since I already know the x over dy, to get dy over dx, we can simply take the reciprocal of the left hand side and the right hand side. By reciprocal, from equation 3, it's still the same as saying minus sine y divided by 1, right? Taking the reciprocal of both sides, then it becomes dy over dx is equals to 1 divided by minus sine y. Alright, from equation 4, we found dy over dx, which is our interest initially. That's what the question asks us to calculate. You have to solve for sine y, meaning calculate for sine y. So sine y can be evaluated two ways. It's either you use your trig identity or you use Pythagoras theorem. For the first one, by trig identity, we know that sine square y plus cos square y is equals to 1, right? From here, make sine square y the subject of the formula. Then it becomes sine square y is equals to 1 minus cos square y. Alright, your interest is to evaluate sine y and not sine square y. If sine square y is equals to 1 minus cos square y, then sine y becomes take square root to both sides. This is the left hand side, this is the right hand side. Square root the left hand side, meaning square root of sine square y equals to square root of 1 minus cos square y, right? Then from here, square roots cancel square. You are left with sine y is equals to the square root of 1 minus cos square y. Alright, you solve for sine y. That is, the y dx is equals to negative 1 divided by sine y. Substitute the expression for sine y in equation 4, then you are done. But in this case, from equation 2, if x is equals to cos y, you can surely reverse the case by saying cos y is equals to x. By saying that cos y is equals to x, right? From equation 2. This equation 2, this is we vice versa. If x is equals to cos y, you see the same thing as saying cos y is equals to x, right? Then from here, call this equation 5. From equation 5, we are having cos y equals to x. Then cos square y is equals to s squared. Call this equation 6. Substitute the expression for cos square y, which is equation 6, into this expression of sine y. Then sine y becomes, okay, then your sine y becomes square root of 1 minus x squared, right? So therefore, the y over the x, which is equals to 1 divided by minus sine y, is equals to 1 divided by negative square root of 1 minus x squared. So this is how you solve the derivative of cos inverse of x. This is how you do about it. Same idea when it comes to tan inverse. Alright.